Hi everyone. So in this session, I'll be talking about another built-in data type in dictionary in Python, that is dictionary. Up until now, whatever we have discussed sequence type data types. So what I mean by that is that accessing all those values and all, I mean those data types, we had to use indexes for that. But in case of dictionary, since this is a mapping type dictionary, we basically utilize keys in order to extract the values from a dictionary. So before getting into the intricacies, I will start by how we can create an empty dictionary. So like like a list, we used to have these square brackets to create empty dictionaries. In case of tuples, we used to have these parentheses to uh, create the tuple. Similarly, in case of dictionary, we use these curly braces to create the dictionary. Now, if I check the type of this variable, I'll see that the class is dict. That is nothing but dictionary. Perfect. So, say for example, now I add a key one, and for this key one, I have a corresponding value as val one. Okay. If and say I add one more, say key two, and say the value is val2. Perfect. Now if I try to print this, I'll get the dictionary where we have these two key value pairs. Okay. Perfect. Now say for example I want to check the length of this dictionary. What I'll do is use the len function like we used in case of list or triples. So if I run this code, I'll see the length to be 2. That is two key value pairs. Perfect. Now say now let's talk about different characteristics for for dictionaries. So let's see one scenario wherein I try to put in a duplicate for key one. Okay. Say for example I put val3. Now, if I try to print this, I see that instead of creating a new key value pair, it has overwritten the already existing key one key value pair. Okay. So instead of val1, now I see val3. That means the values have been overwritten. So, so one thing is 100% sure now that the dictionaries are changeable. That is, it is mutable. So like unlike tuples which are immutable, dictionaries are the one which is mutable. Now say uh, another characteristic, say uh, let's discuss why we say dictionaries to be ordered. The reason why we say dictionary to be ordered, that here we can access values through the keys that we put in, so we consider dictionaries to be ordered. Also, if I try to add a duplicate in case of a dictionary, say for example I have already shown you that, let me show you again. Now say I write a duplicate value for a certain key val4. So once I print it, I see that instead of adding duplicate values, it has overwritten the already existing value. So we do not entertain duplicates in case of dictionary. Okay. Now, say for example, how we can access values. So one way is pretty evident now, that we just put in the key name, and then we can very easily access the value. Another, there's an inbuilt function that is get. So through get also, if we put the key name, we can basically grab the value associated with that. So this is very easy. There are some other functions, some very basic and very important functions in dictionary that really helps our causes. So let's say for example there is a function keys. Okay. So this basically helps us to fetch out all the keys in that those dictionaries. Similarly, we have values. Okay. Here we can see the values, whatever are there in the dictionary, are fetched out. Okay. On similar lines, then there is this items. So basically, item is nothing but list of tuples, and each tuple has the key value pair. Okay. So as you can see, this is a list. Square brackets identify list, and then inside the list, each element is a tuple having the key and the value inside it. So basically, a key value pair builds this tuple, and these tuples build this list. Okay, so this is what we get as an output using the items function. Okay, also if we want, we can say we want to check if a uh, certain key exists in a dictionary or not. So as you must be aware of in operator, we'll use the same thing here. So say for example, I want to check if key 1 exists in the dictionary or not. You'll see, since it exists, it returns true. Okay, similarly, if I try to put something like a key 10, so it will throw me false because this particular key does not exist. Now you would be interested, what if I put in a value here instead of the key? Will that be able to retrieve? Will dictionary be able to uh, check for values instead of keys? So if I do it, I see false. That means that through in operators we can only check for the keys associated, not the associated values. Okay. Now, say for example, what if I desperately want to have the values to be checked using this dictionary? So in that case, what we'll do is that di dot values. Okay. So there's something. So basically, what it will do is that it will just list down all the values in the dictionary, and then we will run an in operator against those set of values, and we will get true in case the values are there. Perfect. Now, say for example, how we can change the values in a dictionary. Okay, so one way is pretty straightforward, that we just put in e, okay, and just put in a updated value, say ABC. Okay, in this case, if I try to print it, I see the val 4 has been overwritten by ABC. Okay, now there's a dedicated function for this as well. Okay, we call it update. So what happens in case of update is that we put in, sorry, so in case of update, what we do is that we put in key value pair in curly braces. So here, if I say put key 1 and say BCD, if I close this, if I try to print it again, I see the ABC has been overwritten by BCD. That means that through update, we can update the values. Now, out of curiosity, I am trying to put in a key value pair that does not exist in the list in the dictionary. So what will happen in that case? Let's check that out. So if I do that, I try to print di. What I see is that that particular key value pair, which is not already existing in the dictionary, is now concatenated to the dictionary. That means that update has a dual functionality. In case the key exists, it will override the value. In case the key does not exist, it will just concatenate the value to the dictionary. Okay, so this is what we can conclude from this. Let's say for example, I want to remove a key value pair. So how will I do it? I will do it using pop function. Okay, I'll just write the key value here, sorry, key name. If I try to print it, I see key 1 has been removed. Okay, now let's see, there a function like pop item or so if I do it, I see that the last key value pair from the dictionary has been removed in case we use the pop item. Okay, now let's reverse our last uh, operation, so that at least we can get two values in the dictionary. Okay, so now if I print it, I see the two key value pairs. Perfect. Now say for example I want to say copy this dictionary. Okay. So by default, this is the logic that would strike our mind, right? So if I do a di1, that means that I am basically trying to copy that dictionary. Let's see if it actually happens or not. Okay. Now if I check the type of this variable, I see that this is a dictionary class. Okay. That's all right. That's exactly what we wanted. Now say if I make a change in d1. Okay. Di. Okay. Let's say I put it to be value 100. Now if I print this, I see the value has been updated accordingly. Now I try to print di1 and I see that here also the val 100 has been updated. What does this mean? That we are not copying the dictionary using this statement. Rather, we are keeping only one dictionary, but now we have two variables to refer to that. Okay, I hope that is clear. So instead of copying it, we are just creating one more alternative variable through which we can access the already existing dictionary. What if I want to copy it? So there is a dedicated function for this, which we call as di dot. So if I check the type of di2, I'll see it to be class dictionary. Now say I again change some value here in, I first print it out. Now I say I change value here in and say now I put val as 1000. Okay. If I print this, I see the value has been updated. Correct. Now let's try printing out di2. But here what we see is that the value has not been updated. So this concludes that using the dot copy function, instead of creating two difference variable, we are actually ending up creating two separate dictionaries. And how did we prove that? How did we prove that? We tried updating di, but that exactly was not replicated for di2. That means now in the memory there are two individual that exist, and updating or adding any new key value pair to one won't impact the other one. Okay. So this is how we can copy the dictionary. Now say for example I have this dictionary di and I have to create an empty dictionary out of this. How will we do it? We have a dedicated function for that, that is dot clear. Now if I try to print this, I see the dictionary to be empty. Okay. So I hope these are the basics and the most fundamental functions of dictionaries are clear now. Now say we have a concept of nested if else, right? We also have a concept of nested for loop. Similarly, on the similar grounds, we have a nested dictionary concept as well. So, what I mean by nested dictionary is, say for di3, I create a new dictionary, key 1. I say this is key sub key 1, and this is ABC. This is, let's see, it's val 1. Now I say a sub key 2. For this, the value is val 2. I close this dictionary. I now create another key in the outer dictionary. Say, for example, here the value is val3. Close this. Perfect. Now, if I check the type of this dictionary, I'll see the class is dictionary. Now, say, how would I access val1? So first, let us go step by step. Okay. So what I'll do is that di3 key 1. So now we get the internal dictionary that we wanted. But this is not our last expected result. Okay, we want val1. So with this particular statement, with this particular statement, we are just getting the internal dictionary. Now we have to put in one extra piece of code here which would satisfy our need. Now I say s underscore key one. So it is key by 3. I'm so sorry. So this is exactly what we wanted. We wanted val1, and this is how we get val1 from a nested dictionary. And similarly, all other options, all other functions for dictionary applies here as well. Okay. Now, I mean, this concept. I just want to add one more point that this concept of nested dictionary could also be utilized in case of nested lists and nested tuples as well. Okay. So, in order to access a nested dictionary or any nested data type, we have to follow this approach wherein we put the key value for the outer dictionary and then put the key value of the inner dictionary. And this is how we fetch the value. Okay. So, this. So after this, so we come to the end of our data type, built-in data type definitions and related functions. In the following sessions, I'll be covering concepts like error handling, file handling. Then we'll start with oops, and that is when we complete the required portion of Python for data engineers. Thank you.